Let us discuss logging now. So, what do we mean by logging? So in our test bench or design, we could have several display messages, correct? So we want to control the display messages, how it gets logged to the run, like the log file, correct? So what we are saying that there can be a lot of display messages, but not all of them are necessary at all the time, correct? You want the default severity of the log message to be error or above, but if you want like some info messages, then you can increase that logging to include the messages. But and then there can be scenario where you want all the display messages to be present from the design, correct? In that case, you might want to use the debug category of message, which will print all the log messages, correct? So what we are trying to do here is we are trying to define an integer log level, and we have defined this integer as like log level value as like if it is 0, it means fatal. So we'll only print fatal messages when this log level value is 0. When the log level value is 1, what we will print both fatal as well as info messages, and when log level is 2, we'll print fatal, info and debug, which in turn means all the messages what we have in our like design and the verif environment, correct? So this again we are trying here, this log level is a runtime argument. So if a user specifies this value, it's fine, otherwise it will only print the fatal messages in our design. Now how do you control this on the respective display statements? So for the respective display statements, you have to categorize using like which display is info, which display is fatal, which display is debug, correct? Now depending on that, you might have to do certain changes to your design. Again, this is since we are like doing in Verilog, this is the way we are doing it. But if you go to SystemVerilog or UVM, there are like additional constructs in which you can specify this directly and control that, correct? So for this example, we are trying to control this using a runtime argument, and then so the runtime argument is log level. So if you see the memory read and write transactions at the interface, these are like when you want to debug something, like debugging when you are how many transactions occurred, what at a particular address, how many times the write occurred, what was the data to that address. So if you need so much of detail, then we might want to print that, correct? So we have classified our mem read and mem write message as debug messages. So this gets printed only when the log level value is greater than 1, which means 2, 3 or like 2 or above, correct? Any value is above 2. The pass messages, correct? Again, if you see there are like we had a couple of pass messages. Pass messages can be useful, but again, if you're running 1 million transactions, so you don't want 1 million pass messages in the, correct? So by default, we only want the error messages, correct? So the error message, if you see, we have not qualified with any log level. Basically, it means that it will be printed always, correct? This fatal gets printed always. Now, if a user wants to include the info, it has to pass the log level of 1. When it passes the log level of 1, means that this pass messages will also get included in the log, correct? So this is the way we control our logging. So how do we pass this log level? Again, similar to the other runtime arguments, we have to do plus log level equal to that value whatever we want to pass. Let us go back to our example to check this. So this is the part of the code what we discussed now, and then if you see, let us like for time being, let us remove this. So if I do a run, and then if you see this, so you see like you don't even see a pass message, you don't even see a like memory read write message, and since there was no error in the design, there was not even the fatal message printed. So this is a very clean report, correct? You don't want, but again, like if you want to include those messages, now how do I control this, correct? Now if you want to increase if you want to only include the pass messages as well, correct? So what you can do like this, plus log level equal to 1. So in that case, if you run it now, so if you see like you see like there are only 3 prints here, correct? But we had sent out 10 transactions, correct? Why is this discrepancy here, correct? Now we said that this num read write represents the total number of transactions, and each transaction is randomized, like it can be a read or a write. So in this particular case, if you are seeing only 3 pass messages, this means only 3 reads was performed, except all was writes, correct? So that is the reason we see only 3 messages, and then that is the case. So if you want to, again we could increase the log level to 2, and then we can see that all the, even the memory interface transactions what we had in our design would get logged. So now you can see like these are like 1 read, and then 4 write, 1 read, again 2 writes, 1 read, and 1. So you can actually see now, okay, there was like 7 write transactions and 3 read transactions, correct? So this is the way you control all the logging of the messages, and it is useful because by default you don't want the entire log to be present. And then now if you say this, you could even run this number of transactions to be any number, correct? Like earlier we tried 10,000 and it failed, correct? Let's try this now. Now earlier, like when we ran 10,000, like it was failing, correct? Now if I increase this log label to 2 and run the same example again, you will see it fail, because if the number of prints for this educational version of the tool is more, then it will kill that particular simulation, correct? So like you see like this, correct? So just changing the log severity, and then we are now able to send like higher number of transactions, correct? So this limitation is not like a tool limitation, correct? It is just that we are using an education version of it, and this education version is to just get started to understand the language as such. And like we must thank this all EDA vendors to providing us such an access to this, correct? So this is the way it works.